Hi, thanks for joining. My name is Kyle Sword. I am the Manager of Business Development for NSG Pilkington.
And I'm Kayla Natividad, and I'm an Architectural Technical Services Engineer with NSG Pilkington.
And today we're going to be talking to you about vacuum insulating glazing, or VIG. So VIG is not new technology. We're going to do a very brief explanation of what that technology is. But primarily what we want to talk to you about today is use case. Why does VIG get used? Where can it potentially be used? And how do we see this potentially growing in our glazing world? So just as a very brief overview, a regular IGU is two pieces of glass. Typically you have a low E on surface 2, and you have, a 1/2 inch to 3/4 of an inch air or argon or some sort of gas to give you the insulating property values. And VIG essentially is the same two pieces of glass, but instead of an airspace in between, it's a partial vacuum in between. And the reason is a vacuum is a very good insulator, so you can get some high performance properties with that. So that's what we'll be talking about today. But first, I'm going to turn it over to Kayla, and Kayla is going to talk to you a little bit more about some of the reasons behind this on code and on the built environment and why we're seeing some pending need on different technologies.
Yeah, so what I want to do is take a step back from even just thinking about what technologies are being used and start talking about what are the energy codes that are driving the adoption of these. If you look at energy codes from a national level down to a local level, maybe even to your optional like LEED or well, or anything like that, what we're seeing is that building energy performance is actually becoming a lot tighter. And we're seeing that since these energy codes being implemented are tighter, the window performance requirements are getting a lot tighter. A lot of this is hitting new construction, so seeing that window requirements are starting to exceed what's generally achievable through traditional IGUs. For example, we see NRCan is proposing a national regulation on windows and sliding doors that gradually increases each year or over the years through 2030. And so by 2030, it'll allow for a maximum U factor of 0.14. As a frame of reference, a traditional IGU with a low E on surface 2 has a center of glass U value of 0.3. So we're looking at cutting that in half essentially. And by doing this, we're going to have to start implementing a lot of new technologies, or really it's existing technologies that just haven't been widely adopted because there hasn't been a need to in order to achieve the standards that we're seeing right now. So Tom Culp recently presented an energy code update for NGA, and he was nice enough to let us use one of his slides, because by no means are we energy experts and code experts, but we like to reach out to the experts to make sure we know what we're doing. And what we see is that in the most recent update of ASHRAE 90.1 2019, he laid out what was needed to meet the U factors that were within the standard for each zone. So starting with zone 1, we see that you're still going to be able to achieve it using a standard low E voltage. Nothing crazy going on there, but when you start moving, zones 4, 5, 6, 7, you're going to have to start thinking of other ways to maybe reach those limits. So adoption of a argon fill, using warm edge spacers, thermal breaks, potentially adopting more than one low E in the configuration. There's just going to be a lot of out of the box thinking on how we're going to go through and achieve some of this. And what we're seeing is in zone 8, so your most extreme zone, you can add all of those things, but no, generally you're going to need to go to a triple IGU. And so as we go through and we start talking about going to triple IGUs and you start increasing weight, you start doing other things. So we're just going to have to start thinking creatively with what we have right now to try to meet these and push your building energy performance forward for all this new construction. Something that we haven't seen before, though, and we're starting to see more of now, is standards being implemented that affect existing building stock. So we've all heard the number that somewhere between 80 to 90% of the buildings in 2030 are already exist today. And so as we start moving all of our new construction and building energy codes forward, we can't leave everything else behind. If we really want to go through and target carbon emission, if we want to go through and target what type of energy usage is happening, we have to start bringing everything into the future with us. And so we're seeing these codes being implemented in New York, we're seeing them being implemented in Washington, and we're anticipating to see them in other regions as well. And so an example of this is Local Law 97 that was introduced in New York. And the basis of this was to reduce building-based emissions 40% by 2030. And this affects all buildings over 50,000 square feet. So essentially, every existing building will have to undergo an audit, energy audit. And if they don't meet their baseline emissions, then they'll be fined. And so now you're gonna have to start thinking of how are we saving, where are we like cutting back on our energy usage and our emissions. Some ways to target this are maybe changing your lighting systems, changing your mechanical systems, and potentially changing your facade if it's poor performing. So now, as we have to start thinking about bringing all of this in and what new technologies we have, I'll pass it back over to Kyle so he can tell you a little more about that exists today.
Awesome. Thanks, Kayla. Yeah, so first I'm going to talk, just a little bit more about VIG technology to make sure everybody really understands what's the difference between traditional, double glazed and insulated units. So when I think about that, again, it's the same two pieces of glass, but if you just took that traditional IGU and pulled a vacuum on it, the panes would suck together, the edge seal would kind of blow in, and your glass would touch, and you wouldn't get any of that insulation value. So there's a few tricks, and really it boils down to three things on how you really define VIG and how that's constructed that are really important. So the first is you have to have a spacer array. So these are little tiny micro dots. It can be a couple different materials, but it's every inch to every inch and a half across the entire face. And then what happens then is as you pull that vacuum, those spacers keep those two pieces of glass parallel and not touching under vacuum pressure. That 0.1 Pascal of vacuum pressure equates to about 1 ton per square foot. So it's really a tremendous amount of pressure. So you have to have a spacer array. You have to have an edge seal that also withstands that vacuum pressure. So most times this is a rigid seal. Traditionally, it's either like a molten glass, like a low temperature molten frit, or it's a metal to glass weld on those two edges. And that's really the most common of those, are the rigid seals. There are some patents out there available for these flexible seals, but in practice, that's not really what's commercially sold yet today. So you got to have a spacer array, you've got to have a way to seal the edge, and then you have to have a way to get the vacuum out. And so the majority of these, you drill a hole and you either put a little glass tube in or have another pumping mechanism to pull the vacuum out of that airspace. There are some designs that don't have that pump out tube where you actually do it in a vacuum chamber or other things. Again, those really haven't started to take off in terms of sales, as I understand. But most of what you're going to see commercially available does have that pump out tube. But what you're left with then is a 1/4 inch overall unit that performs actually a little bit better than that 1 inch equivalent IGU. So the first thing I get questions about is, well, what does all that look like? How does it, does it still look like a regular window? Those little pillars is one of the big questions that we get. We'll say you're going to see all this marking. And to be quite honest, I mean, those are 0.2 to 0.3 millimeter round. So it's 128ths of an inch. I mean, they're really tiny. Even, in a conference room, you can see them, but in a job site, which is what we're looking at on the right, I mean, essentially they're invisible at arm's length away. I mean, they're really, really tiny. The pump out tube, there has a protection cap that goes over it. And that typically is about a 1/2 inch round or something like that. It varies on manufacturer. That's more visible. And in some cases, if you're doing a really small, like true divided light 9/9, you got a bunch of little caps, it becomes an aesthetic issue. But on most projects that are larger size lights or large fixed windows, you don't really see it. And even still, if you actually look at what it looks like, your eye kind of looks through some of these darker colors. And really, if you like the mullions and mutton bars and different things like that, there's a lot of other things that are distractions. So it is, it's something to talk about, but practically speaking, it's not a massive impact on the vision area and what you see. So, it actually looks kind of like a regular IGU in terms of reflection and transmission and all those other sort of things. Really, it's going to look the same as a regular IGU. So when I hear people talk about this, most people today are buying 1-inch IGU or something like that, and they're putting it in a window or framing or sash. The idea of, would you just convert all those 1-inch IGUs over to 1/4-inch VIGs? There are some benefits. There's definite nice things about it because the glass is thinner, so that unit is going to be much thinner. So it's going to be a little lighter weight. You're not going to have the same profiles required. It does have a lower U factor, so that does help you hit some of these stretch targets. The edge seal is kind of an important one in that because it's a molten glass that seals the edge, or some of these other seal mechanisms, you don't have that typical breakdown mechanism that you would with an organic sealant like PIB or something like that. So exposure to temperature, moisture, humidity, sunlight, UV, those sort of things don't break down that edge seal. So potentially the edge seal does last a lot longer. And sound doesn't travel through a vacuum. So you're going to get a really nice STC bump, even at a really, really thin level. And that goes along with these U factor benefits. So there's definitely some reasons, but to be honest, most times we don't see the adoption of people just converting over from a 1-inch to a 1/4-inch because there's so many other changes that go in that space. And really there's other ways to probably get some of those. So we actually see VIG and some of these other emerging technologies, maybe like a thin triple IGU or an aerogel or other kind of mechanisms. Those have a different entrance to the market, we think. And it addresses things besides just that slight increase in performance. So one is dealing with the 1-inch form factor. A lot of times there are jobs that architects want to spec a really thin steel sash that the sight lines don't have the impact of that, that thicker IGU. And it could be on new construction, it could be on existing construction, but there are a lot of times that the sightline really matters to the designers. And historic buildings is an area that we see a huge impact on this. Is if you have a building that's in a historic district or it's on the designated National Register or other things, sometimes you can't rip the windows out. Or if you want to do replacement windows, you have to go through an approval process and they have to sign off on the aesthetics. And so dealing with existing historic buildings, there's a really nice value proposition in that you can just take out the glass and reglaze with this really thin VIG product. Heritage material discussions is another area where we see huge benefits because sometimes we're doing a project right now that has really old bronze single hung window, and they're gorgeous and the owners want to keep them because they're so beautiful. Or you've got old growth wood, or you want to keep them for a variety of other aesthetic reasons. So sometimes even if it's not a historic building, people just want to keep the original sash anyway. And embodied carbon discussions, this is something that we're starting to see just bubble up. But most times when we talk about energy reduction, people are talking about operating energy or operating carbon. So that's how much is the gas bill. That's how much is the AC and the things to run the building. But the other thing that's being talked about is how much energy does it take to make the steel, to make the glass, to make the PVB that goes into those new windows. And when you start to calculate in all those additive energy costs that go into making and doing the restoration, then you look at the operating carbon. It's that how much energy goes into the project and the materials itself. People are really starting to look at those sort of things. So again, this kind of enables you to reduce some of that embodied carbon discussion. And then honestly, so there's sometimes projects just have other issues going on where full replacement just won't work. That's the cost of full replacement sometimes, or the schedule gets delayed out, or there's occupants in the rooms and they don't want to take 2 months or however long it takes to go into these projects. But there's loads of reasons where sometimes, a full window replacement or a 1-inch just doesn't meet what they need for the project. The other area we see nice benefits is if you take a 1-inch IGU, you still use that low E on surface 1, on surface 2 in your outboard light, but you change the inboard light to a VIG pane. Now what you get is what's called a hybrid VIG IGU. So essentially this gives you a triple glaze performance in a double glaze form factor. So if you are having to hit those stretch goals, instead of having to convert everything over to a regular triple glaze, you can just convert the glazing component, put this hybrid VIG in where your regular double glaze would go. Now you're getting triple glaze performance that you can still do the same extrusions, the same weight, the same sizes. The only thing you're changing is the glazing component. So we see that as being potentially good. So really, when we look at VIG and emerging technologies and how we can utilize these, not that there aren't solutions today, it's a different view on how some of these things might add value to our markets and our space. And one is just trying to achieve stretch goals in terms of these performance things Kayla mentioned, but without having to widen the form factor, whether it's in restoration or whether it's in new construction. And then the other is, as these demands on existing buildings get greater and greater, there might be some different solutions that are available in the market space to deal with those existing buildings through a retrofit solution, and really maintain that existing material or design. So with that, I'm going to turn it back over to Kayla, who's going to talk about energy usage for a little bit.
Yeah, so combining what I would potentially wanting to use your existing sash and your existing framing and just replacing the glass itself. We went through and decided to do a simple energy modeling to help show what type of effect switching that out could have on your total building energy usage. So what we did is we used Energy Plus software and the Department of Energy's commercial reference buildings that were developed for this to see what type of impact new technologies would have on a average predetermined building. So the building we selected was an existing building pre-1980. Reason being, we assume anything built prior to 1980 is more likely to be single glazed. Anything built after 1980 is more likely to be built with a traditional IGU. And so this is more where we would be having some sort of impact. The building type is a medium office, 3-story building, over 50,000 square feet. So this would fall under local law 97. And it's climate zone 4A, which is where New York is, what the climate zone New York is in. So we're just kind of assuming this building exists somewhere in New York, and this is what the impacts would be. So what we went through and did was we compared, assuming a picture window with a wood frame. We use a 6mm clear monolithic light, upgraded to a 6mm monolithic low E on surface 2, and then finally a 6.2mm VIG. So here you'll see the total window glazing performance. These performance values were calculated using LBNL Windows 7.5. So they're just a frame of reference of what you might be seeing on site. And so after we went through, we ran the modeling, what we see is that in the office energy performance, the majority of where the impact was by changing your glazing was in your heating and cooling. Heating was predominantly predominantly ran off of natural gas, cooling off of electricity. And our total end uses that encompasses your heating, your cooling, your lighting, your water systems, any mechanical systems in the building. So that's just an overall what is being taken by, or what is being used by the building. So just focusing on the heating and cooling right now, using our standard clear monolithic as a control, you'll see as we move up to just applying a low E coating on surface 2, you get a pretty significant reduction in energy usage for 11% and 9% respectively. But by adopting a VIG, so now we're essentially getting double glaze performance in a single glaze system, we over double that reduction. So now we're looking at 23% reduction in heating and 18% reduction. Whenever you go through and start looking at total end uses, because you are still being impacted by all of your other systems, as we go through, we see that, by applying a low E coating on surface 2, you get approximately 4% reduction in this building and a 9% reduction in this building by installing a VIG. One thing I'd like to note is that this VIG that we selected is a pretty middle of the road performance for VIG. There are VIGs that perform significantly better, and there are VIGs that don't have a performance as this one. So it's a typical average baseline of what you'd expect. But if you wanted to go through and have a higher performance VIG, there are options available and you'd be able to adopt those. And really, I know it's not a one size fits all. This is obviously just a simple example of what your energy impacts could be by replacing your lights. But I would recommend consulting, like hiring an energy consultant to help you with the model of your specific building and see if this would be a viable option for you in that case.
Awesome. Thanks, Kayla. So I'm going to go through a couple case studies on where has VIG actually been installed and what is the practical reasons that actually was selected. So if I look at MIT is probably the earliest and largest project that we've done. And this dates back about 8 years, but MIT had this historic campus. The windows are 100-year-old. They are non-thermally broken steel sash, and they're glazed with 1/4-inch plate glass, 8 foot by 20 foot tall. And MIT, being MIT, said, we want to fix these old buildings, but we want them to look like the original buildings, and we want to improve the energy efficiency as much as we can without changing that aesthetics. So they undertook a 3-year study. And what they did was they said, let's look at each window and let's put in a different solution. So they had in one bay, they did storm windows. In another bay, they reglazed with monolithic glass. In another bay, they reglazed and did thin line IGUs. And then in yet another bay, they actually reglazed and did the VIG. And then every quarter, they did energy analysis, they did IR scans. They did this really, really thorough 3-year evaluation and said, what do we really want to do? And they ended up putting in replica steel sash that was non-thermally broken, that was exactly basically what they took out. And they reglazed that with the VIG product. And the reason is the steel itself was corroded to the point where they didn't think it would last another 100 years. And the VIG enabled them to keep the aesthetics, to keep the look, get as much energy efficiency as they could without fundamentally changing the way that it looked, and it improved occupant comfort and energy efficiency and condensation and all those sort of things. So that was a nice project. And aesthetically, from the outside, and this is one of the most important things with these historic buildings, you don't notice a difference from the exterior. You don't see the caps, you don't see the buttons, you don't see the little spacer arrays. So aesthetically from the outside, it looks the same. The one thing you will notice is when you go from monolithic glass to double glazed, you don't have 2 surfaces of reflection, you have 4. So your reflectivity bumps up no matter what you do. But beyond that, it pretty much looks like regular clear glass. From the inside, you do see this protection cap in the corner. So if you know what you're looking for, you'll notice it and you'll see it. But again, most times your eye is kind of trained to look through the color black, and really you block out and ignore all these big mutton and mullion bars and things like that anyway. So really, it doesn't aesthetically change the inside view significantly. Really, that depends dramatically on what you're looking at as well. This is another picture of the exact same room. I tried to put in worst case, but the outside doesn't change, and then the inside depends on what's behind it. But really, most times it doesn't really change the viewpoint, at least what we can see. The Milwaukee County War Memorial was another large project. This was done back in 2017. It was an Aero Saarinen designed building put in the 1950s, 1955, I think. And the architect was actually hired to do a curtain wall replacement because this is horrifically energy inefficient. It was, non-thermally broken steel sash that was stick built in place, and it was glazed with 1/4-inch wire glass. So this is on the lake in Milwaukee. It's the main staircase that goes between the buildings. Horrible condensation. It was super cold. Got a lot of corrosion resistance. And the architect said, well, let's try and honor Saarinen's design and see if we can restore it. The steel was in good shape. They actually said, we really can restore this. But when they looked at the options for the energy efficiency, they said, well, if we reglaze it with even a monolithic low E, we're not going to get the energy that we want. And they could have reglazed it with an IGU. They could have built IGUs that fit the size. The challenge there was that to do that, they would have had to move these glazing bars, and retapping those glazing bars would have meant 14,000 new holes. They had to patch, re-drill. It added the scaffolding for about 2 months. It added a ton of labor, and the project cost just went up. So they reglazed it with VIG. It ended up getting them everything that they wanted because they could hit the energy efficiency, they could hit the project costs, and it actually ended up being the lowest overall cost of project, and with the highest performance of pretty much what they were evaluating. So it was a really nice fit. And this to me is kind of the case in point where, VIG and these emerging technologies may not be your every project solution, but there are going to be times when this kind of fits a different bill than anything else that's available on the market today. So you look at what the impact was. this is one of the windows that they had, and I think this one got broke by sticking a ladder through it, or something like that with the project. But we had to reglaze it with just monolithic plate glass until the replacement can show up. And you can see on this cold winter day, it's 35 degrees on the inside, a ton of condensation and frosting, and then that's what leads to that corrosion and that cycle of maintenance. The VIG right next to it doesn't frost up. The inside temperature of that glass is about 58 degrees. Your view's better. So really, it's a really nice fit in these sort of scenarios. And then finally, I'm going to talk about use case. Where do we actually see, with all the benefits, with all the description of how the product's made, understanding that the tighter demands on new construction codes and on existing buildings, and where we see some of this stuff get used, there are certain cases where it's going to be a better fit. And that's kind of our feeling is, it's not that we can't do all these things where there's more limited use. It's just that VIG starts to lose some of the benefits and the costs and all the other things that go into it to say it's probably not going to be as great of a fit in these applications. But there are some where it really seems like it's going to be a great fit. So the first is when you're dealing with aesthetic demands, and these are really thin sight line, again, new or existing, really thin steel sash or other types of designs. There is some benefits for having this really thin glass or operable, really thin windows. Retrofitting existing sash or in historic buildings is a really nice proposition there because it enables you to keep these historic materials, these heritage materials, get your energy upgrades, get your efficiency, but keep the aesthetic designs of what's there. And then in some of those cases where you're trying to get energy efficiency, whether it's in retrofitting existing buildings or in, you have these stretch codes that you're trying to get, either retrofitting with that monolithic VIG or using this hybrid VIG IGU so that you're not changing your form factor. All you're doing is upgrading your glazing. Those to me there's really, really nice benefits there. There's a couple others in sound attenuation because, VIG has really nice performance. You get a really high STC with that. And it's not to say there aren't other good STC products out there. There's amazing laminations and acoustic PVBs and, all these other really, really nice products that are available today. The challenge is you can't always get that STC with this really thin quarter-inch profile, and yet can't always get the STC with this U factor kind of combination. So if that's one of your goals, again, there's all these different acoustic codes city by city now and the country, all around. So it might be a good fit to hit some of those markets. The other area that we see VIG having potential use is in use in secondary glazing. So if you think about typically, storm windows, we add maybe a hard coat low E, and you get a nice upgrade in your energy performance, but it's not the same level as a code compliant. There are trade-offs in that. But if you talk about using the VIG as your glazing material in your storm window, now essentially you have a retrofit solution that gets you to pretty much triple glaze performance. It's not going to be a fit for every single project case study where we look at, is VIG a good fit? But there's definitely some that we've done that we said, this is an amazing energy retrofit in this, additive technology. So I think, all those you're going to see, there's really nice cases to say VIG is going to have some good wins there. So again, more limited use. These are areas where there's definitely solutions available with VIG, but you just start to wane on some of the reasons why you would want to put in a VIG in. So safety glazing, there are VIG solutions that are laminated. You can apply films. There are tempered VIG solutions out there, but those tend to add a little bit more cost. Those tend to be not as complex and robust of solutions as maybe some of the other tempered IGU or the blast resistant and other things like that, where you have these really tight requirements on safety. VIG, there's products available. They don't make as much sense sometimes. So if you're talking about a project where you need to do a couple doors, 1% of your overall facade have to be safety rated in a VIG project, those are easy to do. It's when you're doing these large scale VIG safety requirement projects, it just may not make as much sense. And the same goes for these large lights, tall buildings. Most VIG can be made up to about 5 foot by 8 foot. There are a couple products that go up to 7 foot by 10 foot. So you can do some floor to ceiling stuff, but when you're talking about doing that on a 30-story building where you have all these high wind load requirements, sometimes these large lights at elevation, you start to struggle with the benefits. Sometimes you're struggling to meet some of those code compliant things with it when it comes to wind load. You just start to lose some of the reasons you would want to do these. There's solutions available, but they get more complicated. Very small, complex shapes. This is another one that we think is difficult because when you get to these really small shapes, sometimes you can't make the VIG in those configurations. Even when you can, like a 9/9, you got a lot of little buttons. So the aesthetics start to be a concern. Your fixed cost per unit starts to drive the cost value proposition to where that doesn't make sense. So it's not that it's not possible, but there's other solutions that might be a better fit. And then when you have new construction where you have flexibility in your weight or your thickness or your pocket or the design, and you don't have to go to something that's a little thinner or keep that existing portfolio, well, maybe it makes sense to just go to regular triple glazing. But again, there's not always one good solution, but where you have more flexibility in your design and it doesn't drive your cost in other ways, there might be other solutions that are just more competitive to look at. And then lastly, structural glazing. VIG, because those edge seals, the rigid and the flexible ones are a little bit more sensitive. Most times those are going to require some sort of a casement or something to go around the outside to protect them. So really in terms of structural glazing, butt joint glazing and different things like that, VIG just isn't a good fit. Again, maybe there are some designs that might be able to work, but really you're probably going to find there's other better solutions out there available. So with that said, that's kind of our take on VIG. If you have any questions on VIG technologies or anything, just give us a call. Kayla and I are both glass people. We really love the discussions on these sort of things. We're happy to help on anything. And there's a couple other things, there's a few videos that explain this a little better, talk through the case studies, and there's a bunch of different. But again, if you have any questions, we're going to stick around for a little Q&A afterwards, and you are always welcome to reach out to us anytime. Kayla?
Thank you so much for your time.
Yeah, thanks everybody, and we hope you have a great rest of your conference and have a great week.